Hello, everyone. Thanks for joining. I'm Vishesh. So I added the GPU support with KVM, which was released in CloudStack 4.21. Today, I'm talking about orchestrating GPU workloads with CloudStack. Uh, this is a little bit about myself. I started contributing to CloudStack since 2023. I became a committer last year, January, and recently became a PMC as well. So what's in it for you? Before we begin, how many of you here are using GPU with CloudStack? Okay, only Stefan. I was going to ask how many of you are using the new GPU feature, but are you using it with the? Okay, not yet. And how many of you are planning to use GPU with CloudStack here? Okay, that's a couple of hands. So as part of this talk, I'll show you a demo on how to use the feature, including how to configure the host for GPU pass-through, and also some technical details about the implementation in CloudStack, and finally, the current challenges that and the future for this feature. Uh, I hope some of you might remember last year I presented a proposal for GPU support at the conference in Madrid last year. Thanks to that, we got support from some community members, and which enabled us to add GPU support with KVM last year, right? So who's behind this effort? So for that, I would like to thank AT&T and US Signal for providing us with the resources, and ProIO for helping us with the testing of the feature. This wouldn't have been possible without the help from the community. So now let's see it in action. So this is a simulator environment I have set up here. Yeah. Let's log in as a normal user first. So as a normal user, you can see the limits that you have available here. For example, for this user, the limit is set to 20, and I have already allocated 4 GPU devices, so it's showing 16 as available. And to launch an instance, I just need to go to the instances page, click on Add Instance. Everything is same, just you need to select the compute offering, which has the GPU. You can also toggle this filter, which will only show the compute offerings which have the GPU attached to it. So for this demo, let's select the large GPU instance here. And I'll just go with the defaults that we have here for this demo. And let's click on Launch Instance. Yeah, and the instance is launched here. And you can also check the GPU details here. For example, we have this, with simulator, we get the simulator graphics card basic. And you can see the total count to 2 here. For admin user, you can see much more details. Let me quickly log out and show you that as well. Yeah. So as an admin user, you see the same details earlier that you saw, but you can also see the specific GPU cards which have been allocated. If I go to the host details page, I can see much more details about the GPU cards which are available on this host. You get a summary here of different GPU cards and the different profiles. In this demo, this cards pro has been as a simulator, it has kind of split into multiple vGPUs as well. And if I go to GPU devices, I can see more details about the GPU cards and the vGPUs that are present on the host. It also shows you which VMs are allocated here and their state as well. Okay. And once you have discovered the GPU devices, I'll cover that a bit later. To make it available to your users, you just need to create a compute offering and click on Add Compute Offering here and select the GPU card that you want to use for the GPU offering. For example, let's select this one, GPU Graphics Card Pro. And in the GPU profile, you can select the vGPUs here as well. And you can set the GPU count here, which will determine the number of GPU devices you want to attach to that host when it is launched. This GPU display toggle is also here, which when this is enabled and when you launch an instance, so this will try to use this GPU card for display as well. So this doesn't work by default with the GPU pass-through, full GPU pass-through. This only works with NVIDIA's vGPU profiles that you have created. Just a second. Yeah. So once you have created the service offering, you also need to prepare some templates which have the NVIDIA vGPU drivers installed so that they can actually work with this. And if you're planning to use them for display, you also need to set this video.hardware to none after you have enabled the install the drivers. Otherwise, it won't work. You will face some issues with windowing or some cursor-related issues that the cursor is not visible or something like that. So once that's done, the next part you might want to do is configure the number of GPU devices that are available to a single account, project, or domain. For example, if I check the accounts here and the limits for this user, I can see the limits which are being used by it and the limit available for it. And I can also configure the limit from here as well. Same thing is available for domains as well as projects here. And as an operator, you also want to charge users for your offering. So you can charge them based on the basis of the running VM user or allocated VM usage. And if I this. So as you can see, I can see the offering name here, and based on the offering details, I can charge users accordingly for that as well. Another thing to note here is that when I, let's say, stop an instance, let's stop it. Is it this? Maybe it's hard to see from here. Yeah, let's go with this. As you can see, this stopped instance still has the card attached to it. This might not be required for some based on the your requirements. For example, I would like this card to be available to other users if the instance is stopped. So for that, we have a global setting called GPU detach on stop, which is disabled by default. And if you turn it on, now the next time VM with GPU is stopped, it will automatically detach the GPU devices from that instance, and they will be available for your next VM. So just a second. So what can you use these instances for, right? So you can use these instances for display as well. As I mentioned earlier, you need to use vGPUs with NVIDIA for this. And not all vGPUs are allowed to use it for a display. So there are some specific profiles with NVIDIA which are allowed for display only. And you also need to install the drivers for it to work, as I mentioned earlier. And you also need to have an NVIDIA license manager as well, which you need to configure with this instance. You can also use it with Kubernetes as well. But for this, you'll need to install some specific operators which are provided by the GPU vendors like NVIDIA and AMD. And you can also use it for inferencing as well. In this image, we are using, I attached 2 vGPUs to a single instance and tried to use the DeepSeek model with Ollama. So how do I actually enable GPU support for my KVM host, right? So for that, we have this checklist as per which you need to enable IOMMU, disable the novel kernel module. This is for NVIDIA, and install some libraries so that the discovery script works. And if you want to use vGPUs, you will need to install the GPU drivers and create vGPUs. And finally, discover the GPU devices on the host. Let's go into in more detail for this. So first, we need to enable IOMMU, and this setting also needs to be enabled in the BIOS as well. And as per some documentation, it's recommended also to set IOMMU is equal to PT to get the best performance. And this change all goes in the grub configuration here. To verify this, you need to execute this command and grep IOMMU, and it shows something like IOMMU enabled to verify that IOMMU is enabled or not. Once this is done, you also need to disable the novo kernel modules, because if they are being used by the PCI device, it won't allow you to do a full pass-through. Once that's done, we need to install XML Starlet and PCI utils. Because the discovery script, which discovers the GPU devices on the host, requires these two tools to be installed. And if you have an NVIDIA card which supports vGPUs, again, you'll need to install the NVIDIA vGPU manager on the host and follow the documentation to create the vGPU devices. You will also need to automate the creation of vGPU devices here, because after rebooting the GPUs, the vGPU's configuration gets lost. So you'll need to automate that part as well. And another thing that note here is that when you automate it, ensure that each vGPU profile gets the same address so that it doesn't cause conflict with the existing devices which are discovered in CloudStack as well. So once that is done, to discover the devices on the host, you just need to restart the CloudStack agent or use the discover GPU devices command via CMK or the UI. So again, another just quick look through what we need to do for enabling GPU support on CloudStack. But is that it? Not exactly. Again, as I showed you in the demo, you still need to configure some settings for your users, which includes creating the GPU-enabled service offerings, configuring your templates, and there are some global settings which you need to configure as per your requirements. These max account GPUs, max domain GPUs, and max project GPUs just specifies the default that is used in default limits which are used for a user account or domain. Right? So how does it work with CloudStack? So this image shows a default, shows how most of the providers are using, allow access to an instance. For example, if instance 1 needs access to 2 GPUs, I will just do a full pass-through for that. But in some cases, especially for VDI use cases, I might want to actually split a single GPU into multiple devices and share it with different instances. For that, for NVIDIA, you'll need to install some NVIDIA vGPU manager, as I mentioned earlier, and then create the vGPU devices. CloudStack will discover them, and then you can allocate them as well to specific instances. So how does this exactly works, right? So when the CloudStack agent starts on the host, it discovers the attached GPU devices on the host, and then shares these details with the management server. The management server then syncs all the details in the database, and when an instance is launched based on the service offering, it will select what GPUs it needs and which host are they available on, and tries to select the best host that is possible here. And then it passes on the configuration to the KVM agent in which we generate the libvirt XML and launch the instance. So this is the script that we use to discover the GPU devices on the host. This is a simple batch script, and it basically generates a JSON, as you can see. And in this, we have a list of different devices and different details that are required for the allocation of a GPU device. We also added support for customizable agent hooks in this. Earlier, we used to have Groovy-based support, but to provide more flexibility, we also added support with shell scripts to allow the transformation of XML or to allow executing custom commands when an instance is stopped or started. Right. So what's next, right? Yeah, so now let's talk about the challenges that we currently face and the future that holds for the CloudStack GPU support. One key challenge that we face is the limited availability to a variety of GPU-based hosts for both feature development as well as quality assurance, right? So this also ties into the need to validate and continuously improve our auto-discovery scripts and domain transformer scripts. In future, we are hoping to implement the GPU metrics, but as of now, they are only available for vGPU devices that are created, but not for the GPU pass-through. So yeah, so that's all we are planning right now.